Number 5.6, this figure is given to us. Okay, mass of 6 kg is suspended by a rope of length 2 meter from the ceiling. So there is a rope and 6 kg mass is suspended here. Okay, now another 50 Newton force is applied in this direction. So the rope is behaving like this, or it is like this. Otherwise only 6 kg Newton force is applied at the end of the rope, then this would be like this. But when we apply some force here, or when we pull this rope from the midpoint of this rope by applying 50 Newton force, then this kind of situation arises. Okay, now what is the angle of the rope which is made with the vertical in equilibrium? We have to neglect the mass of the rope. Now to understand this, first of all we have to understand the concept of tension. Okay, concept of tension we should understand. Now try to understand this way, that we have a rope. We have one rope which is tied with a rigid support. It is loosely kept right now. Now when you apply some mass here, when you tie some mass here, then what will happen? The mg force will be in the downward direction, and the reactive force, now forces are always in pair, so reactive force to this mg force, that is tension which is produced in the upward direction. Okay, and this tension is found to be same everywhere if this rope or a string is taken to be a light inextensible string. By using this fact, now we can calculate the sum number 5.6. Okay, see here this figure which is given in our textbook. Okay, now see here 6 kg mass is applied. So weight of the object m into gravitational acceleration 60 Newton force is in downward direction. So reactive force which is produced here in this 1 meter string, that is T2, and that T2 will be equal to weight of the object, and T2 will be equal to 60 Newton. This is action force and this is a reaction force. Now we talk about this T1. T1 is the tension which is produced in this particular string, and this is the vertical direction. Let angle theta is subtended. That we do not know, that we want to find. Theta is a question mark. So the component of T1 in this direction will be T1 cos theta, and component of T1 in this direction perpendicular to T1 cos theta will be T1 sin theta. Now this point remains in equilibrium, does not go this way or the other way, it does not fly off or it does not fall down. This point remains there only. So the forces in vertical direction and forces in horizontal direction must be equal in magnitude and opposite in direction. So T1 cos theta must be equal to this weight. So T1 cos theta is equal to T2, and that is the weight. Okay, you can see. Then in horizontal direction, T1 sin theta must be equal to this 50. So T1 sin theta is 50. Now taking the ratio so that I can get tan theta. So T1 sin theta upon T1 cos theta, that will give you 5 by 6. And if you find this value of 5 by 6, that will be 0.8333. And if you locate this value in the natural tangent table, okay, then you will get theta to be about 40 degree. Okay. Now we talk about some common forces in mechanics. Okay, the first force is the gravitational force, which is exerted by the gravitational field of the earth. Okay, and this force acts at any distance without the need of any medium. You do not need any medium for this particular force. Okay, every body on the earth experiences this force. Okay, other common forces are contact force. See, contact force, they arise due to the contact. Now the component of the contact force which is perpendicular to the surface is called the normal force. Try to understand, if the book is lying on the floor, then the component which is perpendicular, because of the contact there is a force, okay, and the force is having its perpendicular component which is known as normal component, or it is called the normal force, and the component which is parallel to the surface is known as the frictional force. So there are two components of the contact force. One is normal force and the other one is a frictional force. Now tension in the string is also a force which is arising, that I have explained in the beginning of the lecture. Okay, because of the object which is tied at the end of any loosely tied string, then the tension is produced in the string. Now force due to spring. Now if you consider any spring, okay, you consider any spring, say for example you have this kind of spring which is kept. This is a spring in its normal condition. Now when you apply any mass at the end of the spring, then the length of the spring increases. The length is extended by an amount x. Okay, then there will be a restoring force. This force due to its weight is in downward direction. Force due to the weight of the object is in downward direction, and the restoring force, or we can say the force which is trying to bring the spring back to its normal position, is the restoring force or the spring force. F is found to be directly proportional to its extension or compression. If you compress the spring, then there will be a compression, then the restoring force will be outward. Okay, or we can say the restoring force when you compress the spring will try to bring the spring to its original length. Here also this restoring force is in the upper direction, okay, and it is found to be directly proportional to the extension here in this case. Now this force is opposite to extension, that is why minus sign we can keep. The extension is in downward direction, this restoring force is in upward direction, and if you put the constant here, then this force F is equal to minus kx. Okay, here k is called the force constant of the spring. Okay, so this is the force which is produced, the restoring force produced in the spring. Okay, this is very easy to understand. Okay, when spring is compressed or extended by external force, then a restoring force is produced, that is F is proportional to minus x. So F is equal to minus kx, where k is a force constant. Okay, for light inextensible string, this restoring force is nothing but tension, which I tried to explain. If the string is like this, and if the mass is tied at the free end of this string, then the weight of the object will be in downward direction. Then the restoring force produced in this, that is in the opposite direction of mg, which is nothing but the tension which is produced in the string. Okay, so these are some of the common forces that we are going to discuss, or rather we will have all these forces in the further studies. Okay, thank you very much.